All right, we are on now to session 8 on electric pumps. The electric pumps, if you recall from the overview, we're talking about the yellow and blue electric pumps. And these are supplying hydraulic power for operation of all components in the yellow and the blue systems. Okay, so, and we're going to look at, remember I mentioned earlier about brake manifold, and I'd come back to that. So we're going to be looking at that here in just a bit as we talk about the yellow system operation. Okay, so one task of the pump, okay, when we talk about the yellow system, is the operation of the forward and aft cargo doors. Okay, I know I made a little comment about that before, so kind of just revisiting this, is we're talking about forward and aft cargo doors. That's operated by the yellow system. The system can also provide green hydraulic power, but it's going to go through the PTU. All right, so where is this electric pump located anyway? It's going to be in the right-hand wheel well. Okay, remember I said the yellow components tend to be on the right in the belly fairing, and the greens on the left. Here we have it here, the right-hand wheel well is where that's at. And that's in forward section between frames 41 and 42 in the yellow hydraulic bay. That's where you're going to find the electrical pump. What about the blue one? Okay, the blue system electric pump, that's in the left-hand wheel well. Forward section between frames 41 and 42. And that's in the blue hydraulic bay. Okay, so yellow electrical pump in the yellow hydraulic bay, well, that's on the right side wheel well. And the blue is on the left in the wheel well. Okay, so let's describe a little bit about this pump. The pump does have a motor, and that's going to come into play in a little bit here. The electric pump provides, of course, the pressure, hydraulic pressure, for auxiliary generation. Okay, the ADPs, remember I mentioned earlier, those are for the main, those are the main ones supplying that hydraulic pressure. But we have electric pumps that are kind of backups there, but they're auxiliary generation systems. You have, of course, a push button switch on the overhead panel that controls the electric pumps. And what makes up the electric pump? You have a motor, so there's the electric motor. You also have a boost pump, and you have the hydraulic pump. Okay, this is supplying pressure to what? Okay, so here, besides operating, I mentioned the yellow system electrical pump, supplying to the operation of the cargo doors, but the electric hydraulic pump is supplying pressure to the right thrust reverser and the high pressure manifold. Okay, there's also an air blower assembly that you need to be aware of. The air blower assembly is there to keep the outer frame of the motor cool. We got to have a way to cool right anytime we have moving parts. So there's the blower assembly. The type of hydraulic pump that you have is a gerotor type, okay, which supplies that flow of fluid to the electric motor. The fluid goes to the drive shaft of the motor, and it keeps that shaft and bearing area cool. Okay, that's what we have with that fluid, as you well know. You also have an inlet impeller. That inlet, it's obviously at the inlet of the hydraulic pump, and it turns together with the pump assembly. And what is this for? I know I mentioned earlier about an impeller to kind of boost, right, increase pressure. Here it's just basically improving that flow. It's a boost too, essentially, but it's moving that fluid to the inlet port of the barrels, and that way it just makes it, it creates better operation of the pump. Just makes it operate more efficiently. The pumps are variable displacement types, and the pump here, okay, remember earlier I talked about EDPs having 9 pistons. Okay, now we're on to the pumps here having 7. So the electrical pumps have 7 pistons, not 9. And the design of this is similar to what I mentioned earlier about the ABEX pump, which has a hanger, so a movable hanger versus a yoke plate. So the way this one is the hanger. It controls the stroke of the pistons, just like I described earlier in the operation when I talked about the EDPs. And of course, that's going to create displacement of the pump, right? Yeah, because you have different effects on the strokes of the pistons. All right, so as far as this performance on this, you have the displacement at 4.4 milliliters per revolution. Okay, and again, you can just refer to the AMM. You're going to have, these are pretty standard, but I want to make sure you don't get convoluted with too much with numbers. But you do have delivery pressure at different flows, different rates. So you have at zero flow, or your delivery pressure at 23 liters per minute, or at 32 liters per minute. Your electric motor is just a conventional induction motor, 3-phase, 115 volt, 400 hertz. Okay, that's standard. And the current consumption at 45 amps, and at current consumption running is 45 amps and a speed of 7,700 RPMs. There's also a temperature switch that's installed there. And so what's, again, the critical threshold here? If the temperature increases to 162 degrees Celsius, okay, that's at 503 degrees Fahrenheit. That's hot. But, if it reaches 503 degrees Fahrenheit, then the switch is going to operate, and it's going to send signals, right, to the overhead panel and to the ECAM. And that, just so you know what it looks like on the overhead panel, it's ELEC, or electric overheat, pretty typical OVHT. You also have a pulsation dampener that's actually installed in the outlet line of the pump, and that's just going to remove any fluctuations that you might have in that pressure of the flow that's coming from the pump. So it's just kind of creating a balance with that when it's coming out. And you can see in the diagram giving you a visual of your air outlet or fluid outlet as well, your electrical connector, seal drain. You can see your mounting bracket. You can refer to the picture at the bottom on that diagram. Okay, the blowout. There's your case drain. Okay, so kind of giving you a visual on that. Okay, now what about the current transformer, and how in the world does this relate? Of course, we're talking about electrical, so we've got to talk about transformers. We've got a current transformer that's installed in the avionics compartment, and that is on panel 107VU. Okay, 107VU. And that operates in conjunction with the current unbalanced detector, because it's going to be detecting any faults in the motor, okay, of that pump. I'm going to make sure it's, the motor's, in phase, and making sure that there's not a problem with the running of that. So what is it doing? It's comparing the flow of current in each of the 3 phases of the supply to the motor. Because remember, I know I just mentioned that a bit ago, but if you're not familiar with electricity and you're curious about it, let us know. We can share more on that. But anyway, bottom line is, it's going to be monitoring that for any kind of faults in the phase differentials. Okay, so it's also possible to test the current transformer. You want to make sure it's, it's doing its job. And that typically, if that's going to be done, that's going to be done along with the unbalanced detector. And there's a push button on the current unbalanced detector, so it can run that test. Your typical supply is 28 volt DC in order to operate that unit. Okay, the phase unbalanced detector, okay, they're both installed in the 107VU, and this has a test button as well. It's a test push button on it, on the top, so that way again you can test that and make sure everything's working right. If there's a fault, it's gonna be able to detect. But operates to detect together with that. When you have these two working in conjunction, it's a pretty good protection, against any problems that are going on, or again, things that are out of phase in the way it's not supposed to be in the motor itself. So that's what those two components are there for, is to detect any faults with that. Okay. All right. There's also a light that's going to come on to show that the unit has operated, okay, and stopped the motor. So, when we have a fault detected, then there's a detector. The detector is going to get that signal from the transformer, and it's going to use that to stop that supply of power. Okay, and obviously it's going to stop the motor. We don't want to continue having a fault and then having something continue to run. So that's what it's going to do. And then there's going to be an indicator light that comes on to show that the unit has operated, okay, and stopped the motor. There's a time delay that's included in the circuits of the detector that stops the operation of the unit. If the unit gets an input signal for only a very short time, that's what it's going to do. Okay. When the unit has operated, it's going to stay in that condition until it's set again. And when does it set again? Okay, it's going to set automatically when the supply of power to the unit is stopped. Okay, through the operation of the either one of the pumps, the electrical pump push button switch. Okay, and then start it again. So you can do, that's how that works. And then of course you have the testing there. And then it shows you a picture just so you can get an idea of what the unbalanced detector looks like and your current transformer. Okay, both of those are in the 107 VU in the avionics compartment. Okay, all right, so now let's kind of talk a little bit about the operation of our auxiliary hydraulic power system. We're talking about the yellow at this point, and then I'll talk about the blue one. But the yellow, okay, the operation of the yellow, and by the way, the blue is going to be very similar, but I'm talking about the blue or the yellow right now. So the operation of the yellow electrical pump obviously has a switch on the overhead panel. That's on the 40 VU, okay, the famous 40 VU. If you're not familiar with Airbus, and you're just getting familiar with this. I did mention this in the overview. So 40 VU, that's going to be where you're going to have all those switches, and your 50 VU, if you recall, is going to be kind of your maintenance service panel, okay. But here, 40 VU controls that electrical pump. So when you push the button and release it, then the on light's going to come on, and then the electric pump's going to start. Okay, and when that happens, you're going to see the lower display unit of the ECAM show the operation of the pump. Okay, you can also start the electric pump from the cargo door operating panel. That's just an alternate way. If that's the case, then there's a time relay 6MJ that's energized from the cargo door system that's enabling the electric pump to start. So if you do it that way, that's what that is. 6MJ is what gets energized. That's a relay in order to start that pump. Okay. The pump's going to get that supply from the reservoir of the yellow system, right? Yellow hydraulic system. And it's going to pressurize the system to 3,000 psi. Okay, we know that. So again, going through that process, we know how the operation works with, the pistons, etc. So that's what's happening here with the electric pump. Now, remember I mentioned how the right-hand thrust reverser is getting its pressure from the electric pump of the yellow system. So here, output from that electric pump goes to that thrust reverser. And also remember the high-pressure manifold. So then from there, from that manifold, you're going to have the supply sent to all of the different, all the different applications, which of course includes the cargo doors as well. Okay. All right, so kind of gives you an idea there with the operation on the yellow. And you have, the diagram showing you the yellow auxiliary hydraulic power operation. Okay. And we've introduced here, remember, the thrust reverser, so you'll see that on the diagram. Okay, you see that on there. Okay, and then of course you get your switches on the 40 VU panel, so it's showing you that. And it's showing you that 6JM I mentioned earlier, that time relay. And that's responsible for starting that electrical pump. Okay, all right, so now let's talk about the brake pressure relief valve. This is in conjunction or in association with the yellow system. So what does the brake relief valve do? Relief is relieving, right? So we don't want to have too much pressure when we're operating the parking brake system, okay, which is what we're talking about right now. So that's why you have that relief valve. It's going to ensure that we have a relief of some of that pressure for that system. Now there is a brake manifold. The brake manifold is located in the right-hand wheel well. Okay, after the lower wall on frame 47, that's going to be next to the brake accumulator for the yellow system. Okay, so they're all together there. The relief valve is actually installed on the actual brake manifold. Okay. Now on the brake manifold, we've got the pressure transmitter. We have to have that, the pressure relief valve, and the check valve. Okay. The valve itself has two parts to it. You have the high pressure relief valve and also the manual depressurization valve. Okay. So the body has two valves. It also has a flange to attach to the assembly, so it can attach to the brake manifold. And of course hydraulic connections that you have to the manifold are of the bobbin type. Remember I said a lot of them are bobbin type. Okay, now the valve itself is a poppet type valve. So you guys, if you've been through jam films before, I'm not going to go into all the operation on that. It's because it's the same. It's a poppet type valve. You have a spring pressure and holds that, pop it against the valve seat. Same situation, same stuff. All right, now when does it open and when does it close? Okay, so the valve's going to open. It's going to open at 237 bar. Okay, that's at 3,436 psi. Okay, and it's going to open also at 240 bar, which is at 3,480 psi. Okay, and when does it close? It's going to close when the pressure decreases to 220 bar, which translates to 3,190 psi. Okay, so kind of keep that in mind. So valve opens at, I'm going to put it in psi. Okay, so valve opens at 3,436 and 3,480 psi. It closes when the pressure goes down to 3,190. Okay, so now just a little bit on the manual depressurization valve. That's a ball type valve, and the hydraulic pressure from the inlet is going to hold that ball in its seat. Okay, and then that's going to obviously shut, keep the valve shut. Okay, so just describing a little bit on the depressurization valve. You also have a pressure transmitter mentioned earlier, that you have this, and it's installed in the brake manifold of the yellow system. Okay, that's what we're talking about right now, is the yellow system. So it's going to gather data, right, from there, and that's going to be sent to the wheel brake system. Okay, the transmitter there is getting supply, just so you know, of 28 volt from the brake system. All right, and then you have the diagram showing you the location, the components in relation to one another. So your hydraulic pressure transmitter and relief valve brake system, your manifold. Okay, so you got that on that picture there. Now what about the blue system? Okay, we're talking about electrical pump operation, but the blue electrical pump. Okay, it's fully automatic. Okay, it's possible to stop it, but it runs automatically, and it's supplying when any of the engines starts. Okay, so that's when it goes. It then just continually goes until both engines stop. Of course, same thing. 3,000 psi is what it's producing. Its output pressure, and the I'm going to mention the system accumulator. We're going to get into that in another session, but this electric pump in the blue system is constantly changing, okay, its output flow, because we're talking about being able to maintain a stability of the pressure. And the system accumulator, because each of the systems has an accumulator, is going to make an allowance for any temporary decrease in the pressure because of the response time of the electric pump. So they're kind of working in conjunction with one another. Main thing is just maintaining a stability, okay, for that pressure. All right, so let's just say that both engines stop in flight. Then what's going to happen? We're talking about the blue system. So then the electric pump is going to continue to operate, as long as it has electrical power. And as long as the APU is working, it's going to continue. And if that's the case, then we're going to have a compression of the nose landing gear that's going to stop. Okay, the compression of the nose landing gear is going to stop the electric pump. Okay, so just if both engines stop in flight, then the pump of this blue system will continue to operate as long as we have AC power. Okay, in this case, the compression of the nose landing gear stops the electric pump. There's also a time delay circuit in there that operates for 2 minutes. Okay, so it keeps the pump going for 2 minutes after the compression of the nose landing gear, and that just makes sure that the pump doesn't stop immediately when the aircraft lands. It's going to give it a little bit of time. Now, if there's a complete electrical failure, okay, so we have no AC power supply for the electric pump, then what's going to happen? Okay, then we're going to have the rat automatically operate and pressurize the system. So it's kind of think about that priority. I think about the, right, when we're talking about priority, power priority, this is it right here, you know. So if we can't get if the pump, and we have engines fail, and then we have the electric pump going, but then if for some reason we lose electrical power to the point where we can't get the electric pump to be working and that stops, then we have the rat that automatically operates and pressurizes. Okay, so you have that going on as a chain, again, power priority, and just kind of a chain of events with that. Okay, so the system has temperature and pressure sensors, of course, installed in different places. Here you've got the monitoring that's going on, and that's going to obviously show up in the ECAMs and any fault warnings that need to be shown on there. One of the, of course, the other threats is overheat. So we got to have a temperature switch in the motor in order to, you know, send that signal over to the ECAM in case that happens. So you have that. And so with that, what's going to be displayed, you're going to have your the lower part, okay, of the ECAM is going to, you know, that's where the message is for the overheat. And then you also have the blue elect pump, okay, that's going to be in the upper display status page. Now, what if this temperature decreases? If the temperature decreases, obviously, then the warnings are going to actually stop and everything's going to be good. You have the two push button switches in the flight compartment that control the blue electric pump. Again, back to the 40 VU, that's where they're located. So the crew members can use it to stop the pump when there's a fault. If there's something wrong, they can stop it, because otherwise it's in an auto position. Okay, and then of course if there's a fault, the fault lights, you know, legend's gonna come on and off, which, you know, which come on is whatever is necessary at that point. You also have a blue pump override, so that's OVRD on the push button switch, and this is going to be on the 50 VU panel. Okay, the maintenance panel, that's where this blue pump OVRD, your override. Okay, and that's where that's located, and the on legend will light up when applicable. So you have that, and it's possible to start the electric pump on the ground, obviously when the engines are not operating. Okay, so, and just kind of a extra information here, if you want on the blue pump override, that's located on the maintenance manual, that's controlling a solenoid valve. Okay, that solenoid valve of the leakage measurement system. Okay, and that's just strictly, this is strictly for maintenance only. And you can see the operation, you know, on the diagram of the blue system. Okay, and you can see where, you know, what the applications are. Okay, so hope that gave you a better idea. And again, diagrams help here as I'm explaining, kind of giving you orientation with the electrical pumps. You have yellow and the blue, and then I talked a little bit about the brake pressure relief valve of the yellow system, and locations of these, of the components related to the electrical pumps. Okay, so we're going to go ahead and move to our next session, which is session 9. We are on to session 9. This is going to be on monitoring, indicating of the pressure in the various hydraulic systems, and then also we're going to go into understanding a little bit more about the ground internal leak test. All right, so on monitoring, okay, obviously we got to make sure the hydraulic pressure is where it needs to be all the time. So here we're looking at different locations within the 3 hydraulic systems, and we have detectors. Okay, we also have transmitters because we want to get that information over to the flight compartment on the ECAMs. So with here you have the pressure switches. Those are all downstream of the pumps, whether they're the engine driven ones or electric pumps. Those are all downstream. You also have the transmitters, so there's 4 of those that are getting their supply of 28 volt DC, and that's coming from the bus bar 103 PP that's supplying 3 of those transmitters that are installed on the high pressure manifolds. And then we have one for the brake manifold, so again receiving the same amount of electrical supply. The signals that are from the pressure switches are going to be used again to give the indication of low pressure. So we want to make sure we know if there is low pressure, we have that indicating there. So those are given by different signals, the chime, and also the information that's gonna translate into the lights that are going to come on, like your master caution, and also the lights on the ECAM display, which of course is amber if there's something wrong. And then also the same thing goes for the pressure monitoring indicating for the master caution, or excuse me, for that it's going to be, if it goes too high, then we're going to have the same indications on the ECAM, as well as the master caution warning light coming on and the single chime audio warning to let the flight crew know about that. Then the ground internal leak system, we want to make sure we're able to detect any kind of leakage whatsoever of the hydraulic fluids. So with here, we're able to measure that in different specified limits. And this is just enabling you to make sure that the condition of the components, are going to be okay, because if you have leakage, you're going to start affecting, right, the integrity of the components, which is going to lead to damage, and of course that just becomes a domino effect. So with the ground test rig and the flow meter, those are going to be used to supply and measure the flow of the fluid. So we have 3 different parts to this. We have the ground leakage measurement manifold, the solenoid valve, and we also have the push button switch in the cockpit. And with the manifold and the valve, those are both installed in the high pressure circuit. Okay, and the valve is controlling the flow of hydraulic fluid between the HP manifold and the ground leakage measurement manifold. Okay, so that's its job. That's what it's doing, is it's controlling that flow there. So what happens when you push that button? Okay, you push that one that controls the valve. Okay, that's going to be energized, to supply that fluid. That's going to the manual valves of the manifold. All right. So, and just so you know, the valves of both the blue and the yellow hydraulic systems are always connected to the aircraft wiring. That's a given. And of course they're energized by the push button switch that's operated in the flight compartment. Now there's the solenoid valve of the green system, because I just mentioned about the blue and yellow, but there is the valve for the green hydraulic system, and that's usually it's not connected to the wiring. So remember, blue and yellow, the valves for the blue and yellow systems are always connected to the wiring, whereas we have a difference here with the green hydraulic system valve. That one is usually not connected. Okay, instead there's like a dummy receptacle on the structure that it's connected to usually. That's on the green one. So there's a connector, of course, installed on the valve that enables that to be connected to that dummy receptacle. And so what is this doing? This is to avoid the loss of all power to the flight controls in case there's not any supply needed to all 3 of the valves. Okay, so that's what it's there for, to avoid that loss of all power. It's also necessary to connect that wiring connector. Okay, this is after it's removed from the dummy connector. You connecting that wiring connector to the valve before operating that push button switch. Okay, so then after all the maintenance is done, then you're going to have to reconnect that wiring connector to that dummy receptacle again. Okay, so giving you a chain reaction on that. As far as the yellow electric pump, and this is on all of the aircraft, the yellow electric pump starts. Okay, remember, yellow is connected to the cargo door operation, whether it's opening or closing. So that's going to, that's actually going to start. Okay, and that's what is that going to do? Okay, it's going to affect the flight controls. It's going to prevent the movement of the flight controls when we have the operation of the cargo doors. Okay, remember I mentioned that before. Just kind of going into more of the details here. So electrical power is supplied, okay, to the valves. So there's no hydraulic power that's supplied to the PTU in the flight controls. Okay, it just isolates that energy. Okay, so there's also on the hide there's a leak measurement valves BGY. So you'll see that as a label, and it's again HYD, and then leak measurement valves B/G/Y. And there's those 3 push button switches, one for each system, obviously. And again, this is on the 50 VU panel. It's controlling that, and you can see on the diagram the layout of it. Okay, and your choices there. And it just kind of shows a blowout, a little bit of the valves. Okay, so now that we're looking at the manifold, I'm talking about the ground internal leak system. We are going to, there's, obviously the 3 manifolds, ground leakage measurement manifolds, one for each system. And what does the manifold look like? Okay, so in our describing it, we have 2 pairs of inlet ports. Okay, 2 of them are labeled as A, the other 2 are labeled as B. And then there's 3 outlet ports. Okay, so you have 2 pairs of inlets, and then you have 3 outlet ports, and those are labeled as C, D, and E. And only at one time you have only 1 inlet port from each pair, being used. The ports which are not used are sealed. Okay, and you also have check valves. You got 3 check valves and 3 two-way valves, and all of those are spring-loaded poppet type. Like I mentioned before, those haven't changed as far as their design. Okay, and those are just located, or those are selected to open, for ground maintenance. Okay, all right. So the valves, just looking at solenoid valves, you have the 3 two-way solenoid valve that's controlling that fluid to the manifold. Okay, to the leakage measurement manifold. And that's installed in the green and blue. Okay, and then you have another valve that's installed in the yellow hydraulic system that's different from the other 2. So just remember, I'm separating out the green and blue. Okay, so the solenoid valves for those. And then there's another one that's not like the ones for the green and blue, and that's for the yellow hydraulic system. Okay. They operate the same way, so nothing changes that way, but as far as the way they look, it's different. Okay. All right, and then just kind of giving you a little bit more orientation, you'll see on the diagram kind of their isometric views here of the manifold. Give me a little bit of a blowout of the valve that's on the manifold. Okay, so now, how does this operate? Of course, it's gonna, as far as its electrical supply, it's coming from service bus 601 PP that supplies that 28 volt DC to operate the valves. So what happens when the plane's in the air? So when we have a plane in flight, we're going to have the solenoid valve that's open. Okay, so that's de-energized, and then you're going to have the manifold. The valves on the manifold are going to be closed. Okay, and inlet port A is going to get hydraulic fluid through the solenoid valve. And this is a divider type, so we've got, the fluid that's divided into 3 flows. Okay, and each of those are going through the check valves to the outlet port, of the applicable valves that are closed. So from the manifold, what happens? So then it leaves the ground leakage measurement manifold through the outlet ports. Okay, so we got the inlet ports with that coming in with the solenoid valve open, Okay, and the valves on the manifold closed. And then we have, again, inlet ports are getting that hydraulic fluid through the valves, and then it's getting divided. And then now what? From the manifold, we have outlet ports that are supplying that fluid to the user systems. Okay, so you also have fluid that's going through the manifold through inlet port B, because remember I said there's A and B, and that flow again is divided into 3 flows, goes to the inlet port of the applicable two-way valve. Okay, so when it goes through there, you have the valve that's closed, then what's going to happen? You have valve closed, then the fluid is going to stop. Now, as far as ground maintenance tasks, you're going to, this is ground, not in flight here. We got a push button switch, okay, on the 50 VU, okay, right, the maintenance panel. And that is set to close the related valve when you operate that push button switch. Okay, so what happens when you do that? Then you're going to be closing the HP inlet ports, and the HP supply port is connected to the LP return. So there's no HP fluid that's going to the inlet port A of the manifold. Okay. Now, again, measuring is involving a ground test rig and also a flow meter, and all that's connected to the ground service supply, a ground service panel. Supply HP fluid. So all that connected to the applicable ground service panel supply, all that supplies the fluid to the system. Okay, it goes through the manifold to the inlet port B, and then the fluid divides and goes to the inlet ports of the 3 two-way valves. Okay, all right. And then the diagram just shows you a little bit of operation. This is from the 50 VU panel. And you can see the push button switches for each of the systems. Okay, and then what how it's affecting going to the affecting the solenoid, activating the solenoid valve on the HP manifold. Okay, and then your normal aircraft normal supply or ground connector. Okay, so it gives you a good idea just of, or orientation at least, on when we talk about the ground internal leak system and kind of the flow of what happens with that. Okay, we are finishing. We just finished out with the 9th session, and now we're going to go ahead and do some knowledge checks. I'm just going to mention some of them just to go over some of that, and of course you can refer to your handout that goes along with this, and just again, that's your goal is having that as a review for the test. But I'm going to go ahead and just cover some of it, not all of it, because there are a lot of questions. Okay, so moving on, the next question here, the 3 reservoirs of the Airbus hydraulic system are all the same size. Is that a true or false statement? Okay, it's false, right? Okay, question number 28. They are all designed to stay pressurized at the normal temperature for how many hours? 24 or 12? Okay, it's 12. What is the location of the blue reservoir? Is it aft of the main landing gear door on the left side of the aircraft? Or is it front of the forward bulkhead of the main landing gear bay? Okay, the answer is the first answer, after the main landing gear door. What is the location of the green and yellow reservoirs? Okay, same options. Okay, that was going to be front of the forward bulkhead of the main landing gear bay. Okay, so continue on. I'm going to skip to question number 34. What is the backup for the low-level switch in the event that it fails to operate? Is it contents transmitter or pressure transmitter? Okay, that's going to be the contents transmitter. Okay, question 35. The standard operating pressure for the reservoirs is 35 psi or 50 psi? Okay, the answer is 50. Question 37. Where is the water separator installed? The reservoir or the reservoir pressurization unit? Okay, that would be the reservoir pressurization unit. All right, question 40. Most of the components of the reservoir filling system are located on the green system. Is that true or false? Okay, that's true. Question 41. What is the connection for a pressurized ground supply? Okay, just making a distinction between unpressurized and pressurized ground supply. So what is the connection for a pressurized ground supply? Is it a coupling socket or the flexible hose? That's going to be the coupling socket. Question 42. Where are the engine-driven pumps located? Accessory group, gearbox, or hydraulic compartment? Okay, that'll be your accessory gearbox, right? All right, question 44. To what is the Vickers pump connected? Okay, your choices are movable yoke plate or the movable inclined cam surface. And that's also called a hanger, by the way. Okay, for the Vickers pump, it's actually the movable yoke plate. Okay, to what is the ABEX pump connected? Okay, that's going to be the other option. Okay, that's going to be the movable inclined cam surface or the hanger. All right, question 47. Both the yellow and the blue electric pumps are located between what two frames? Frames 63 and 64 or frames 41 and 42? Okay, that would be the latter, frames 41 and 42. All right, the 48. The electric hydraulic pump supplies pressure to which component? Is it the right thrust reverser and HP manifold, or the left thrust reverser and low pressure manifold? Okay, it's the first one, right thrust reverser and HP manifold. 49. There's a pulsation dampener installed in the outlet line from which electric pump? Is it the yellow or the blue electric pump? Okay, that wouldn't be in the blue. Okay, in the outlet line from which, from the blue pump. Okay, question 50. On which panel is the current transformer installed? 50 VU or the 107 VU, which by the way is in the avionics compartment. Okay, it's going to be that 107 VU. 51. The phase unbalance detector protects which component? Okay, phase has to do with, with motors. So the answer is motor, because you have motor or boost pump. That's going to be motor. Question 53. What is the function of the brake relief valve? Okay, option 1, to protect the parking brake system from overpressure or to protect the parking brake system from overheating. It's going to be number 1, to protect the parking brake system from overpressure. Where is the brake manifold located? Is it left-hand wheel well aft lower wall on the frame 47 or right-hand wheel well aft lower wall on frame 47? Okay, that was going to be the right-hand wheel well. Question 57. From what components are the data sent to the visual on the ECAM display unit and for fault action from the ECAM? Pressure switches, okay, your first choice, pressure switches and pressure transmitters or pressure and temperature transmitters? All right, that's going to be the first choice, pressure switches and pressure transmitters. All right, 58. There are 2 types of pressure switches installed downstream of the pumps. What are they? Okay, option 1 is solid state and electronic, or type 1 and type 2. Okay, it's the latter, it's type 1 and type 2. What is the low pressure threshold for all 3 systems? Okay, what's it's going to be, the choices are 1450 plus or minus 72.5 psi or 1750 plus or minus 72.5 psi. Okay, that's going to be the first one. Okay, 1450 is your low pressure. Basically, you're going to have warnings go off when it goes below 1450. Okay, plus or minus 72.5 psi. All right, question 60. If the pressure had previously gone below the threshold, but then it increased, to what pressure will cause the cancellation of all those warnings? Is it 1850 psi or 1750 psi? Okay, the answer is the latter, 1750 psi. Okay, let's go to 63. What components make up the ground internal leak test system? Option A shows solenoid valve, your push button in the cockpit, okay, and ground leakage measurement manifold, or check valve, push button in the cockpit, and ground leakage measurement manifold. Okay, it's going to be the first one, right? Solenoid. It's a solenoid valve. That's part of it. Okay, question 66. Each of the three ground leakage measurement manifolds is each of the manifold. Okay, the configurations of those is different from the others in configuration. Is that true or false? Okay, it's false. They're actually all the same. Okay, how many pairs of inlet ports? Okay, I'm not asking how many inlet ports there are. How many pairs do you have that are on each of the manifolds? Okay, is it 2 or 3 pairs? Okay, it's 2. Okay, 2 pairs of inlet ports. And by the way, there's 3 outlet ports. Okay, let's move to question 70. How many check valves and how many two-way valves are there on the ground leakage measurement manifold? Is it 3 and 3 or 3 and 2? Okay, the answer is the first one. It's 3. There's 3 check valves and 3 two-way valves. All right, question 71. The 3 two-way solenoid valve is in each hydraulic system controls what? Okay, the supply of fluid to the leakage measurement manifold or the supply of fluid to the LP manifold? Okay, that's going to be the first one, the supply of fluid to the leakage measurement manifold. Question 73. Of the 2 types of solenoid valves, which one is open during flight? Okay, the 3 two-way or the 2 two-way? Okay, that's going to be your 3 two-way. Question 74. During ground operation, if the related solenoid valve is set to close, then the HP inlet port is open or closed? Okay, that's going to be closed. But if its solenoid valve is set to close, then the inlet port is closed. All right, so that just gives you an idea of some of the knowledge checks. There are a lot of them, so just again make sure that you go over, you know, in your own time, obviously your self-studying, is make sure you review the questions on here, because that's going to help you a lot with passing the test. Remember, you need to get 80% or better. Okay, all right, we're going to go ahead and move on to our next session. All right, we are now on to session 10. Again, I just hope that helps to break up or divide these different, different components into sessions, just to give you, again, just to break it up and compartmentalize it a little bit better. Your system accumulators, okay, as far as just describing what they look like, so you get an idea of just a general idea. They're the cylindrical type, and if you haven't seen different ones, and hopefully you have, but there are different kinds of accumulators in different aircraft. But here, this is a cylindrical type with an internal bladder. This is a bladder style accumulator, and the metal body of the accumulator has an outer layer of Kevlar, and that's just Kevlar. If you're not familiar with Kevlar, which, just in case you're not, it's extremely strong material, has multiple uses across different industries, and certainly in the aircraft industry, it's being used here with the design and manufacture of the accumulators. The bladder itself is made of rubber, and and that's being able to isolate the nitrogen, which is typically used. That nitrogen, just separating that out from the hydraulic fluid. There's as far as the Capacity of the accumulator, it holds roughly about 0.26 U.S. gallons, okay, about 1 liter. And the gas pressure estimated at 130 bar, which translates to 1,885 psi. Okay, so that's the gas charge pressure. I'm going to put it in psi, is 1885 psi. You also have a gauge for the nitrogen pressure. Okay, and that's just a direct reading dial indicator type, and that's attached to the gas manifold, which is attached to the gas port. Okay, the gas port is just located on one end of the body of the accumulator. It's the connection for the gas charging valve, and also for the what I just mentioned on the gauge. Okay, so that's where that is located. The gauge is just showing the pressure in the accumulator, right? It can indicate up to a max of 3,600 psi, but it's going to do it in steps of 100 psi. So you have your intervals of 100 psi, but just so you know, as far as the indication max on that gauge, it's 3,600 psi. Okay, and as far as its accuracy, it's about plus or minus 2.5%. So just kind of getting close to, to what it actually is. As far as the system accumulator for the green one, for the green system, as an example, that was in the main landing gear compartment close to frame 42, and it's to the left of the low pressure manifold. The yellow system accumulator is in the right hand belly fairing. Okay, so it follows where other components are for each of those systems. And the blue located in the left hand belly fairing. So makes sense where those are located. And you can see on the diagram, it's not an actual photo, but this particular diagram is showing you the accumulators and kind of a blowout, showing where it's underneath the plane, and then just showing you the blowout of each of those. Okay, it shows you the pressure gauge at one end and your charging valve. Okay, so kind of, I guess the one thing you want to be aware of on this one, just again, because accumulators are short accumulators, but as far as here, just know the capacity. Okay, the volume is 0.26 U.S. gallons. Okay, and you have a gas charge pressure of 1,885 psi. Okay, so if there's any takeaway on this one, let it be that. So just kind of take note on that. All right, we are on to session 11, and this is on the power transfer unit, and also just on the manifold. Remember, PTU is just an auxiliary system. Okay, this is just available there in case the main pumps aren't available. So here, what it's used is just transferring that hydraulic power to the green and the yellow systems. So if we have a failure of one of the engine pumps, then the PTU can be selected to to kick in and work. Just making sure that we have the right pressurization for the systems for maintenance. PTU, where's that located? It's going to be in the center of the wheel well, okay, of the aft bulkhead. Okay, and that's going to be above the PTU manifold. So they're, PTU, but the PTU manifold, obviously they're going to be close together physically, and that's located in the center of the wheel well. That's going to be zone 148, by the way. So components of the power transfer system, we have a couple of solenoid valves. We have the PTU switch. We also have the isolation coupling, as well as the PTU itself. Okay, so the transfer system, it's always armed when the hydraulic systems are pressurized. Okay, so it's always there ready to go, and that way the crew can, and if they want to, they can switch it off if they want. The connection between the two systems is mechanical, and just so you know, there's a separation of them, as I'm talking about, from the green and the yellow systems. That way, you can't have fluid to get from one system to the other. There's an isolation. Okay, so when you have the isolation coupling disconnected, okay, that's only during ground maintenance operations, just so you know. That isolation coupling is only disconnected when you're doing ground maintenance. And when that happens, of course, there's no transfer of power. The power transfer system is, obviously has the power transfer unit, and that's transferring hydraulic power between the two systems, the green and the yellow, right? All right, so then you have the operation of the PTU, that can be stopped. So that means it's going to be disarmed from the flight compartment. Okay, now the PTU itself is a variable displacement unit, and it's also coupled with a fixed displacement unit. So it's a combination of type as far as that way of being able to distribute. So with the variable displacement unit, that's connected to the yellow system, and then the fixed displacement unit is connected to the green hydraulic system. So with the variable displacement unit, okay, is varied in order to maintain that required running and breakdown pressure differentials between the systems. Okay, so that's what its function is. That's why it's, we have a variable type unit there, is to deal with that kind of thing and making sure, handling that pressure differential. So with the displacement of that, it's controlled, just so you know, by means of a control, which is going to sense, that delta pressure. Okay, delta pressure is just that change, that differential. All right, so the variable displacement unit is at a maximum displacement during the power transfer. Okay, that's going to be its peak is when it's transferring energy from the yellow to the green system. Okay, and then it's at a minimum displacement during the power transfer from the green to the yellow. Okay, so max when it's going from yellow to green, and minimum when it's transferring power from green to yellow. That might be a test question, so you may want to underline that in your notes. Okay, so the variable displacement unit, okay, what does that include? What makes up that unit? Okay, well, we have the hydraulic servo valve. We also have a cam. Okay, the valve's going to get that input from that pressure differential. That's all starting in that PTU. Okay, and that's going to control, of course, the displacement of the cam, which is going to turn, kind of go back into basically affecting the stroke. That's what that's there. What that's for. Being able to transfer that energy. Okay, and that's controlling that differential pressure. And you can see from the diagram, you can see there where the valve's located on the power transfer unit manifold, on the PTU manifold, and then also the isolation coupling. Okay, and then you can see the kind of the isolated picture diagram of the isolation coupling, but you get to see where it's where it's located within related to one another on the actual manifold. Okay, all right, so as far as our connections on the unit, there's 3 of them. You have 3 on the fixed, and you have 3 also on the variable displacement unit. Okay, so 3 and 3, and those are going to be your high pressure, your low pressure, and your case drain. Your seal drain connection on there is a standard hydraulic union. Okay, and then the high pressure and your case drain connections, those are also standard, so nothing changes there as far as the type is the same. Your low pressure connections are your self-sealing quick release couplings that you would have there. Your solenoid valves, you've got those there that are installed in the PTU supply line. Okay, and that's for each system. It's for the green and the yellow. You have them for each of those, and they're operating together to let the PTU operate or not. Either way, but that's what that's there for. Those valves. So when they're energized, then you're going to have the spool move into the port in order to close the valve. Okay, and then when the solenoid is de-energized, then the spool's going to move away from the port, right? Just the complete opposite in order to open it, in order to open up the valve. Now, what about the coupling? You got the coupling, it's installed in the supply line, and it's just your quick release coupling, which seals automatically when it's disconnected. There's also a ratchet lock to make sure that it stays connected. Okay, and you saw in the diagram how that's installed on the PTU manifold of the yellow system. Okay, now let's just say that you have a leak. Okay, so you have on the aircraft, let's just say that a leak, you find a leak, and it's showing that the inner plastic tubing has melted in 3 different locations. So overheating of the hose. Okay, so what is causing overheating? You know, we talked in another instruction about friction and how that can affect, obviously, create heat, which is going to cause damage. So this is what is happening. You can have friction on that wire, and it's gonna overheat, and that's not what we want, because that's gonna lower the integrity of that, which can cause a leak. So yellow system, you know, similar construction, if there's a possibility of that similar leak occurring. So how are we going to stop that? How are you going to prevent any overheating of the hoses? Okay, you want to introduce new hoses, okay, at the green and the yellow pressure side of the PTU, which are stronger, obviously, and more able to reduce the movement of that braided wire. So obviously it's important to make sure you have the right hoses in there to handle just being able to be strong enough in case there's any kind of friction, then you're not going to have that potential problem. Okay, so on the yellow pressure side of the PTU, you can reroute that hose. The attachment can be modified. Okay, and you can relocate the couplings. Again, just kind of it's more of a design issue. But and then it shows you on the diagram again, just kind of. But that's what I was going to bring up, is that you can have overheating of hoses, and that's going to become a problem. Okay. The manifolds themselves, I know I talk about the components right now, the valves and whatnot, but as far as the PTU manifolds, most of your components that you'll find are made of, just made of that aluminum alloy. Just being able to handle, you know, having the integrity there to handle its function. So here, again, it's machined, you know, in order to, just like your HP manifolds, your low pressure, your PTU manifold is manufactured just similarly, with being able to have different components put on there, just with different dimensions. So you have those connections between the manifolds and the components of a certain type, which is your bobbin type for a lot of them. The kind of same thing here. With what components that all besides valves, your solenoid valves, that you're going to find on the PTU manifolds, you're going to have check valves. You're going to have your priority valves. And then you also have a normal braking selector valve. So that's all, those are the components that are on the PTU manifold. Okay, now the PTU kind of is a go-between with connecting the main system to the power transfer unit. Okay, that's what that is there for. So what a manifold is being able to do is have these components to connect one system to another. So here we have this with the manifold. As far as how it does that, we have different outputs, right? So with the connections, we have a couple of things here. We got 3 outlets, we got 2 inlets. So with the inlets, let's start with that. You've got an inlet and outlet from and to the PTU. You also have 1 inlet for the HP manifold, of course 1 outlet for the HP manifold, and then of course you got your outlets to the normal brake system and also to the consumers. Okay, and those are going to be, you know, downstream of the priority valve. Okay. Okay, and of course, just a reminder on priority valves, you guys probably already know, but you know, obviously, you know, not all the systems are using the same pressure, or you know, required to have the same pressure to operate. So there's going to be a priority valve where when there's some of those user systems are not being used in flight, you know, then it's going to be able to stop the supply of that fluid to those particular user systems. Okay. So what happens is it's going to close on those ones that are not going to be used. If the pressure is too low, it's going to shut that supply off to those particular ones that are not, you know, critical to the aircraft. Okay, and just so you know, the thresholds on this priority valve, it is going to close at 1841 psi. Okay, which is 127 bar. So you kind of, I mean, again, I'm throwing in the other measurement so that you're starting to get familiar with the different equivalences. Okay, so it closes at 1841 psi to about 1885 psi, and then it opens at 1958 psi, which is 135 bar, to 140 bar, which is 2030 psi. So those are your thresholds for opening and closing of the priority valve. Okay, you also have check valves. Okay, those are, going to be controlling, controls together with the other check valve, the flow of fluid, right, going to the manifold. So those are installed there. You've got the, of course, solenoid valve that's controlling the flow of fluid that's going to the normal brake system. Okay. And just kind of a extra thing on the priority valves, you have 3 different modes of operation. You've got, the mode of operations are going to be one, you have more pressure downstream of the valve. So then the valve's going to let fluid flow from port B to port A. Then you have that the system pressure is low. So the valve is going to close and fluid cannot get from port A to port B. And then of course you have full system pressure. Okay, and the diagram showing now, it's showing you the brake selector valve with the priority valve and the solenoid valve. Okay, so let me just go over a little bit on the normal brake selector valve. This one's a 3-way type. It isolates the normal braking system when the solenoid's de-energized. Okay, so solenoid de-energized, then it's going to isolate that normal braking system. Okay, so when that happens, the normal braking is not selected. Okay, or another possibility, the pedals are released. Your check valves, I'm not going to go over again what they are because they're the same as what I mentioned before. So, it's your cartridge type and your inline type that you same here on the PTU manifolds as you find in the HP or LP. Okay, so let's talk a little bit on the operation of the power transfer unit, and then get a little bit more on the description of it. But as far as the operation of it, you don't want to have the unwanted operation of the PTU, okay, while it's on the ground. So, we need to make sure we have some switches and relays that are involved so that we don't have that problem. So they operate together. I'm talking about the switches and the relays. So they're operating to supply power to the solenoid valves under certain conditions. So let's see what happens. When does it operate? If we have the PTO operating, it's going to operate when if the aircraft's on the ground. It's going to operate when you have no engines running. That's one. Also, the nose wheel steering is activated. And also the PTU, okay, the PTU push button switch, so that's what it's going to show on the panel. On 40 VU, when that is not set to the off position. And, okay, so this is all different conditions. The electrical pump is not in operation for the cargo door operations. So that's one instance where the power transfer unit will operate when the plane's on the ground. Okay, is all these different conditions. Okay, now what else? With the PTU, we can have the electric pump in operation to close the cargo doors. And that's when it's not going to operate. Okay, so I just described to you when the power transfer unit will operate. Airplane on the ground, there's no engines running, the nose wheel steering is activated, and you have the PTU is not set to the off position. Okay, and electrical pump is not in operation for the cargo doors. So the opposite, right? So it's not going to operate if you have the electrical pump running to close the cargo doors. Okay, so that's when it's going to shut. It's not going to operate. And then, so airplane's on the ground. Airplane is on the ground, and there's one engine, at least one engine's in operation. Then you're not going to be able. The PTO is not going to operate. And not only that, but you have one engine going, and the park brake is in the on position. Okay, the other condition is at least one engine's operating, and you have the park brake in off, but you have the nose wheel steering deactivated. Okay, so there's an opposite there, when earlier we have to have the activation of the nose wheel steering for the PTO to operate. Okay, and then the last thing on not operating is the PTU push button switch is set in the off position. So the light will be illuminated. So if you see the PTU light off light illuminated, then PTU will not operate. Okay, there's also a test that can be done, I say like kind of a check of the PTU. There's an Engine Master 1, that being put in the on position, and then you have Engine Master 2 put in the off position. Then the PTU cannot operate if, again, you have electric pump in operation to close the aircraft doors. So it makes sense, with that. And there's the electrical diagram showing the PTU operation. Obviously, after you have, assuming you have electrical supply, but you can see that from left to right on the diagram with the switches opening and closing. Okay, when they're energized. Okay, and closed. Okay, so transfer of power, just kind of giving you a little bit. We've got the PTU is just going to automatically operate when we have one of the hydraulic systems is about 500 psi more than the pressure in the other system. Remember that key thing about 500 psi, and that's the difference. That means that one system again has more 500 psi more pressure than the other. Whatever irregardless of whatever pressure it is at that point, in time. But if one is 500 psi more, then that's when you get the PTU actually operate. So the difference of pressure between the two systems is going to move that servo valve in the cam, right? And that's going to cause that change in the stroke in the motor, enough to basically kick in the PTU. Okay, now remember I mentioned about the back and forth of whether you're going from green system to yellow system, or you're transferring from yellow system to green system. So let's look at the condition where you have the green system, okay, and you're talking about a transferring to yellow system. If you have the green system that's less pressure than the yellow system, then the stroke increases to its maximum. But if it's the other way around, if you have the yellow system that has less pressure than the green system, then the stroke decreases to its minimum. Okay, obviously just the flip side, just the opposite. All right, and then you have variable displacement on the green system being less pressure than the yellow. Then you're going to have the variable displacement unit operating as a motor, and the fixed displacement unit is going to operate as a pump. Okay, so, and then kind of similarly with when you have the yellow system having less pressure, you're going to have the variable and the fixed displacement units then operating as a pump and a motor. So it's switched. And then it just kind of shows you the diagram here with the switches. Okay, a bit more of a description involving the temp transmitter as well, showing your isolation coupling. There's your power transfer unit kind of in the middle. And of course your overhead panel. Okay, and then as far as what you have is displayed, displayed on here, you've got on the hide page, it's going to be on the lower ECAM, and that's where you're going to have something, the symbols having to do with the PTU. for the green, and also for the yellow system. So with the green system, those are shown in green color. Again, it just shows the outline of it on the display, and that's when things are in auto position, everything's good. Of course, if there's something not quite right, then you're going to have an amber color outline. All right, so green system, solid green. Okay, so you're going to have an outline when everything is good. When you have the engine pump low pressure, then you're going to have a solid green color. Solid green color on the PTU symbols for the green system. And same thing with the yellow system. It's going to show a solid green color when there's a yellow engine pump low pressure. Okay, now when is it going to show a solid amber? Because I was talking about you've got a solid amber color with the the PTU symbols for the green system is shown in a solid amber color. Okay, when there's a green engine pump low pressure together with the PTU fault. Okay, that's in conjunction with. And then you have also the PTU symbols for the yellow system are also shown in solid amber color when there's, again, together with the PTU fault and the yellow engine pump low pressure together. So either one of those systems, if there's a fault issue, then you're going to have a solid amber color. Okay, and those are in the lower ECAM display. Okay, and then you can just kind of see, you can see the PTU status symbols on there on the diagram, giving an orientation, of what it looks like, the way it's displayed on there. Okay. All right, so it kind of gives you an idea with the power transfer system and indications on there, description of what we have as far as the different components, also located on the PTU manifolds. So you have, what those look like, and kind of just get more orientation with description of them. Continue on with our last session, which is on the operation of the RAT. Ram air turbine. Okay, so on the RAT, this here, it's going to extend when we have a failure of both engines. Okay, so as far as its function, if both engines fail, then there'll be an automatic extension if the aircraft airspeed is more than 100 knots. So that'll happen there. Also, it can be done manually, so the flight crew can actually bring it down or extend it manually from the cockpit. All right, so on here, where is the RAT? Where is it located? It's installed in the belly fairing on the left side. Okay, on the left side. So you have the actuator that's going to extend that RAT into the airflow. Okay, so the conditions, again, I mentioned failure of both engines, or you may have a total electrical failure, or you may have where you have the failure of one engine, and you have an electrical generator failure of the other engine. So that in combination will also automatically extend the RAT. All right, so as far as components, just to give you a brush stroke, you got the RAT control panel is on the blue control panel, okay, on the ground service panel. And then you have the actuator, you have a hydraulic pump, you also have a leg assembly with its pivot, okay, and then you have the RAT, okay, the turbine itself. Okay, so to describe a little bit on the RAT, and you can see a picture kind of that's showing the the RAT frame, the door, of course your turbines, a twin blade, and the actuator. Okay, just to note, you do have a de-icing device. You also have a stall protection device regarding the RAT. The de-icing device is installed in the nose of the turbine hub, so that's where that's located. And what's the critical point? It's trying to prevent it from freezing there. Obviously, it's from not forming ice, so it wants to keep it above the 32 degrees. So here, the critical temperature or minimum that it needs to keep it at a bare minimum, is 37.40 degrees Fahrenheit or 3 degrees Celsius. Okay, that's a minimum. And that prevents the icing conditions on, at the turbine hub when the rat is extended. Okay. And then we'll get into the stall protection that's actually on the hydraulic pump. I'll get into that a little bit later. Okay, so just different things that you have. Of course, you have your components in the left belly fairing because that's where the rat is located. The only thing that's not there are going to be the selector switches. Obviously, you have that from the ground for retraction. You have operations, your controls at the rat control panel, and in the selector switches, of course, in the flight compartment when the crew wants to, have that deployed. So you have that. Okay, so just to note, the blue auxiliary hydraulic power system, which is just also called the blue auxiliary system, is going to supply that hydraulic power from the rat to the blue main system. Okay, so if there's an emergency, then that blue system is going to supply the hydraulic power, for the aircraft. And then that's also going to help with generating electricity so that there's electrical power available as well. And of course, that's why you have the CSMG, the constant speed motor generator, that's going to, allow that electrical power to be available in that emergency situation. Okay. All right. Just a note on, some of or I should say the way the de-icing device is you have a heating device with magnets, essentially. You have an aluminum plate, and there's also samarium cobalt magnets. So those are part that make up that de-icing device, just so you have some knowledge about it. Okay. Now the turbine itself is a variable pitch unit. It is a twin blade. And there's a mechanical governor and the pitch change mechanism that are installed in the hub. The hub itself is designed a certain way because it's trying to, lessen the probability of developing ice on it. So its size and shape is engineered, with that in mind. Okay. You also remember I mentioned the leg assembly. You do have a leg assembly, which is the mechanical and hydraulic connection between the pump assembly and the aircraft. And you have the main part of that leg being a one-piece forging that also includes attachments for the other components. At the bottom, of course, you have that's where the turbine is. And at the top of the leg assembly is a pivot, okay, where that attaches to the aircraft. Okay, so lower part of the leg assembly, that's where the turbine. At the top of the assembly is where it connects to the aircraft. Okay. Okay, so what about the speed of this turbine? Okay, the rotation of it, just kind of giving you a range of RPMs for it, is 4,800 to 6,540 RPMs. Okay, so you have that rotation speed range, okay, because you're going to have a blade pitch angle change. Okay. I mentioned about the hydraulic pump. I'll speak a little bit more on that, but that's where the stall protection is actually installed. Okay. All right, so what happens here? You've got a governor with this, and it's going to mix the counterweight, okay, the blade counterweight, and the governor and the spring, and just using aerodynamic forces to adjust the blade pitch angle. Okay. And then it also has an index mechanism that's actually in the front of the leg assembly that's going to lock that turbine hub assembly in the correct position. Okay, that's just an index mechanism. It's basic stuff. So turbine hub has the markings on there, so you can easily align between the turbine hub and the index mechanism, and that's just enabling the rat to be stowed. Okay. Now, as far as degrees, because there's, you know, certain things to be aware of as far as, you know, what happens at certain degrees before full extension of the rat. So let's just say, for example, you have, you know, an extension going on. Then the rotary assembly is locked until not more than 10 degrees before full extension. Okay. And also just to be aware of the clearance, okay, between the rat doors and the blades. Okay, we're talking the turbine blades is very important. Just the clearance is 19 millimeters, just so you know. Okay, so the idea with the index mechanism and putting it in the correct position is just being able to, you know, protect the components to make sure there's no damage being done with the doors, the rat doors, and the aircraft structure. Okay, now what about the pump? I wanted to go a little more detail with that. The hydraulic pump is a standard axial piston type and has 9 pistons. It's the same mechanism I've mentioned before when we were talking about pumps. You know, we talk about different pumps when I was talking about the Vickers and the ABACs. You know, you have cam, you know, and then one of them in one style anyway. So here you've got one that goes against a face cam, okay, and then you have a plate. So then you got that same mechanism, you know, that I described before on that. Now, this is, remember I mentioned about the anti-stall or stall protection device. This is actually installed in the hydraulic pump. So with this anti-stall system, it's making sure that the pump holds that fluid pressure, you know, at the start of the turbine. Okay, when the flow demand is more than the available flow, it still wants to, you know, it's got to maintain that so it doesn't stall. Okay, so that's installed there for that reason, to prevent that. And of course, the, you know, diagrams help to see the relationship between the different parts. Okay, and just kind of another note on the anti-stall part. There's the idea here is to keep efficiency when things are running. That's its primary job, is to maintain efficiency. Okay, and as far as the actuator, so that was a hydraulic pump. I'm talking about the actuator that's attached to the top end of the leg assembly and the mounting frame. Of course, that's going to, you know, get signals so that it can extend the rat into the airflow. Okay, and it does so with the force of a spring. So with here and extending the rat, you know, you don't need, I should say the system doesn't need hydraulic power to do it, but it does require, you know, you have to have the pressurized system, okay, blue system, in order to retract the rat, which happens on the ground. Okay, so you don't need it when it's not needed when it's extended, when it's needing to extend it, but hydraulic power is required for when you need to retract it. Okay, so if you look at the diagram, there are 2 solenoids there. You can see that, and then there's one proximity switch. Those are at the top of the actuator. So when you have those 2 solenoids activated, you know, it's going to release a lock that's going to cause that rat to extend. Okay, and of course, when we talk about, you know, you could have when at least one of the solenoids is energized, that it would actually do that. So you've got this kept in the extended position, and if for some reason one of those solenoids malfunctions, you know, it doesn't matter, you're going to still have that, you know, extension of that rat. It's still going to happen because one is only necessary. There's 2 on there, but only one solenoid energized is good enough for, you know, for the extension of that rat. There's also the stow proximity switch. So, you know, after playing on ground, there's going to be an indication on the ECAM system that, you know, that there's going to be an ECAM system or ECAM display that the rat is extended. Okay, so stow proximity switch gives a signal to the ECAM system if you have the rat actuator, okay, extended. Okay. All right, and then the turbine assembly, that's just what gets put into the airstream, okay, extends there. There's a cable. So here you've got a stop on the pivot. Remember I mentioned the pivot at the top of the leg assembly earlier? Okay, so that's going to do what? What is that connected to? Okay, this pivot is actually connected to a control cable that attaches to the index lock plunger. Okay, so the index lock is going to release the turbine hub about 8 degrees from full extension. Okay, which is going to cause the turbine blades to turn. So that's now kind of a sequence of events on operation a little bit. Okay, I know I mentioned the pressure switch, but there's the pressure switch along with the stowed switch. Okay, at the top there. Okay, and just kind of remember I mentioned about the range of the turbine speed. Here, if we have an airspeed that's less than 92 KEAS, okay, that's Knots equivalent airspeed, then the turbine speed is going to decrease less than the governor operation range, okay, of the 4750. Yeah, I said 4800, earlier, but here we're talking about if it decreases less than the operation range of 4750 RPMs. Okay. So when airspeed drops, then the turbine speed is going to decrease. When the RPM is between 3800 and 4200 RPM, then the anti-stall system keeps that output of the pump in balance to the airspeed of the at the turbine. So I mean, it's just maintaining. It's like kind of the limits, limits that are here in order to keep a balance going on with those changes. Okay, and I'll just kind of mention a little bit on the RAT. Some of the control indications that you'll see. The RAT control panel, you're going to have an on and off switch. Okay, that's just on and off switch, and that's to switch off the electrical power, which is a 28 volts DC. You have a stow reset switch. Okay, so stow reset switch. There's also a RAT stowed indicator light, just indicating that the RAT is stowed already. And there's also an interlock warning light. Okay. And there's a lamp test switch as well. Okay. Of course, the stow reset is, operates the retraction of the RAT, right, to stow it away. On and off is toggle, basically a safeguard, has a safety guard on it. It's just a toggle switch. And remember, on off is for the electrical. And then there's a lamp test push button, just to test the warning indicator lights. So you have those as well. Now on the electrical and hydraulic override push buttons, you got the RAT emergen man on or RAT man on PB. Okay, your push button switches that are installed in the flight compartments. So remember, RAT and emergen man on, okay, manual on, and RAT man on. Okay, so let me just talk about the RAT and emergen man on. Okay, that is on the ELEC power section of the overhead panel. So just look there, and that's where you'll find it. That overhead panel, by the way, is 21 VU. So remember, RAT and gen man on switch is on the 21 VU panel. 21 VU panel. Okay, so those switches are there for the flight control to the flight crew to extend the the RAT. And then you have that, but then you have also the RAT man on. So that was RAT and emergen man on, and so now the RAT man on switch connects electrical power, the 28 volt DC from the hot bus 1 to solenoid 1. Okay, so hot bus 1 to solenoid 1. Okay, and then when you have the RAT and emergen man on, it connects the 28 volt DC power from the number 2 battery through the circuit breaker to solenoid 2. So rat emer gen man on connects number 2 battery to solenoid 2, whereas rat man on connects hot bus 1 to solenoid 1. Okay, so I hope I didn't confuse you. That's it'd be better if we were in a classroom here and I can be on a whiteboard, so you can just kind of follow along that way. But that's okay. All right, so, and again, it just gives you kind of there's a diagram that gives you some indication here, and then some of the photos that we have along. Of course, also, if you need additional material, to access, we can get that, because we're building, we do have our photo library, as you've, for these Gen Fams. So obviously you have to have purchased this, but you have access to that, just to enhance what we're talking about right now. So, I just wanted you to be familiar with rat man on, rat emer gen man on, okay, and what it's doing there. Okay, just to reiterate, retraction happens on ground only. Okay, so let's kind of go over a little bit on there's the functional test that there's a functional test that can be done, and there's also a retraction test. I'll just kind of mention that to you. But during the functional test, you can actually test the hydraulic pump along with the mechanical governor. That's but you do it obviously on the ground. So there's a tool. So this is the tool I will mention. It's in the back of the rat, and that's what you use for this functional test. Okay, it's a rat ground test tool. Okay, and then of course you need hydraulic power, like a ground supply of hydraulic power to do it. But that's that's what you can do. And then there's another one. It's a retraction test that's operated through the rat control panel. So the one you have an actual test tool, ground test tool, and then the other one you're doing at the rat control panel, which is part of the blue ground service panel. Okay. Okay, so giving you some idea on, just some familiarity with those things. Okay. All right, so, and of course, just one extra thing on the leg assembly, although, you may not see it on not everything's covered on the diagrams, by the way. Okay, it's just a fact. But because there's a lot of, they can have a lot of different things, but there's a blade index mechanism. Okay, just like we have index mechanisms for a host of other components, as you well know, because you've done this, been around this long enough. But on the when you talk about the turbine, there is a blade index mechanism there. Okay, and that's just being able to be there to hold the turbine under any conditions that go on, right? Things are constantly changing, in flight, so things are always going. It has to be able to withstand that. Okay. The other thing too, a little bit more on the leg assembly, as far as what else can you find. There's a gerotor pump in the leg assembly that's supplying the hydraulic servo power to the pitch change mechanism. Okay, a lot of different mechanisms going on here, which is pretty cool. But anyway, so you have that pump there. So what's happening? You have that supplying the hydraulic servo power to the pitch change mechanism. That's why the pump is there. So when the rat is stopped and there's no pressure, then the blades are going to be held in that fully coarse position. So that's what that's there for. And of course, I know I mentioned that there's a turbine index lock. So when the rat is fully extended into the airflow, then you're going to have a turbine index lock that's released, and the blades are going to start to turn. Okay, and then you get the pump going to supply pressure. Okay, and then you got the changes on the blades. Okay, so that's that. And we kind of give you an idea on the leg assembly and actuator a little bit better. You have a limit switch, micro switch as well. Okay, the limit switch limits things, right? It's going to limit, the supply of electrical power to the retraction module. Okay, at some point it's going to stop when obviously the rat's already fully retracted. So that's what that's for. Okay. Okay. There's also I'm talking rat ground retraction. Obviously the retraction happens on the ground. We got some check modules as well. So I just want to give you an awareness on this one. There's a rat jack control module. There's also a ground check module. Okay, and then I'll just kind of go over some components on the ground check module. But here on the jack control, okay, there's ground check, and I'm on jack control module. So this is it's just the way it's described, but it's a retraction module, but it's installed in the rat compartment and left belly fairing, okay, where the rat's located. So most of the components are there other than what I mentioned earlier. So this particular module is a 2-position 3-way solenoid operated. You have a valve. Okay, that's what it is. The control panel controls it, and it's used to retract the rat. Okay, so you're going to have that whole process with the solenoid, getting energized, and then it moves the pilot valve, which provides the fluid to go to the retract side of the actuator. Okay, and then the ground check module, this is installed also in the same area, and what it's doing, it's isolating the rat from the high pressure system of the aircraft when it's retracted. Okay, it also makes the rat able to be supplied, basically it makes it possible for the rat to supply the aircraft system when necessary. Okay, as it can. Now the components of the GCM, okay, of the ground check module, that's what GCM is. There's different things. You have a warm oil bleed restrictor, okay, which is connected to the high pressure system of the aircraft. You have a low pressure bypass and check valve, so both check valve and bypass valve. And you also have a pressure switch, okay, which is, the reason why you're doing that is when you're doing a ground test of the rat, and that's what the ground test kit. Okay. And then there's the diagram to kind of give you an idea of what I'm talking about here, and from where it's located as far as your what frames or between what frames there. And so you have that, and it's showing you there's the pressure switch. You got a flow sensitive valve, bypass. Okay, there's your warm oil bleed restrictor as well. Okay, so that gives you some idea there. All right, so just that's covering quite a bit, giving you some heightened awareness on the pumps, the leg assembly, turbine hub assembly, what's there, what's installed in the nose of the hub, etc. Regarding all of that. So now let's go on to our next and final sessions. Pretty short, but I did want to address it. It's just the extension operation of it. And if we're going to follow a sequence of events, let's kind of follow this along. And we'll also talk about a little bit of a testing. Okay, so let's just kind of go over this a little bit, and then we'll do some review of some of the test review questions. Okay, so obviously the doors are closed, right, in the rat compartment, until the rat's deployed. So, they're going to be, you're going to have those doors closed, and this is the retracted position. The leg assembly is connected to the doors. okay, and it keeps those things closed. You also have the index lock mechanism on the leg that locks those turbine blades so they can't turn. Okay, just keeping it safe and secure that way. Your extension, of course, is going to get that command from either the flight crew manually, giving that input, or it's going to automatically extend when the aircraft is more than 100 knots in airspeed. So when those happen, then what? Remember, it only takes one solenoid. Remember, there's two solenoids at the top. It only takes one solenoid that to energize in order for the extension of the rat to occur. So, if one's not working, the other one's, one's working, it's good enough. Okay, but there are two solenoids there. If they both operate, that's great. But that's going to release the retract lock, which is going to allow the extension of that rat. So you got spring pressure that's going to allow that extension, or that's going to affect the actuator, which moves the rat into the airflow. Then you're going to have contacts. Okay, you got contacts that are going to stop, basically going to close the stow limit switch, and it's going to send that signal to the ECAM, letting the flight crew know that's happened. Then so we have the doors are going to open automatically. You've got the disengaging automatically of the index lock mechanism. That's going to disengage when the rat is about 5 degrees from its full extension. Then once that occurs, then that's kind of the safe zone, if you will, for the turbine blade to actually, the turbine to actually move. Okay. So then the turbine moves. You got fluid, flows, goes from the outlet of the high pressure pump through the flow sensitive valve, and of the ground check module, and that's going to go from high to the low pressure system. Okay, now remember the gerotor pump. Remember I mentioned that earlier. Okay, so that's supplying servo pressure because it's kind of as needed as the turbine speed increases. Okay, that's going to be supplied like that, and then you're going to have your blade pitch angle decrease. Okay, so what's happened when you have the flow from the rat pump increase? That's going to close the flow sensitive bypass valve. Okay, and when that's happening, it's going to stop that warm oil bleed. Okay, so kind of giving you an idea there. Okay, so that's it for operation as far as your extension and retraction. And so now we're going to close this, this off with knowledge checks. And the knowledge checks that we're going to go over here is going to be, your review questions essentially, are going to cover material from sessions 10 through the one we just finished, which was session 13. So if you recall, session 10 was accumulators, and PTU was the next one, and then we got the rat stuff. So let's go ahead and start this off. Question 75: the system accumulators have rubber bladders that isolate what element from the hydraulic fluid? Okay, your two choices on your handout there is nitrogen or oxygen. So which one do you believe it is? You're right. Okay, it's nitrogen. All right, 76. What is at the one end of the accumulators that stops overpressurization? Okay, just try to remember here because it's... Okay, so there you have two choices: pressure relief valve or an oil valve. Okay, this is in the accumulators. Okay, the answer is the second choice. It's an oil valve. Okay, that's the answer. 77, what is the gas pre-charge pressure for the accumulators? Is it 1885 psi or 1750 psi? Okay, the answer is 1885. Remember, pre-charge pressure for accumulators is 1885. Okay, question 78. What is the total volume of the accumulators? Okay, your two choices, 0.26 gallon or 2.6 gallons. All right, the answer is actually the first answer. Okay, 79. The green system accumulator is located in the right hand belly fairing. Is that true or false? Where is that green system accumulator? Okay, the answer is false. It's actually in the main landing gear compartment. Okay, 80. We're on to PTOs now. Okay, what is the purpose of the PTU? Remember, there's only one. Okay, here's your first choice. To transfer power between green and yellow systems, or to transfer power to the blue hydraulic system. Okay, it's the first answer, right? I mean, if you're transferring, you know, from one to something else, not just having one by itself. Okay, so 81. The PTU makes it possible for the yellow system to pressurize the green system for maintenance purposes. Is that true or false? Okay, the answer is true. Okay, 82. Where is the PTU located? Okay, option 1, in the right-hand wheel well in zone 148 above the PTU manifold, or is it option B, in the center of the wheel well of the aft bulkhead, zone 148 above the PTU manifold? Okay, remember, it's option B. Okay, it's the second choice. It's in the center of the wheel well. Okay, 83. In what condition is the power transfer system when the hydraulic systems are pressurized? Okay, there's two conditions. It can be an armed or not armed position, or, you know, condition. Okay, the answer is the first choice. It's in the armed position or condition. Okay, 84. During ground maintenance only, the disconnection of the isolation coupling deactivates power transfer capability. Is that true or false? That's actually true. That's true. Okay, 85. The power transfer unit is a variable displacement unit coupled to what? It's coupled to something. Okay, option 1 is check valve, or option 2 is fixed displacement unit. Okay, it's the latter. Okay, 86. The priority valve that is installed in the PTU manifold has 3 operations. Name one of them. Okay, is it partial system pressure or full system pressure? Okay, it is full system pressure. That is the answer. Okay, 87. Some solenoids on the PTU manifolds are LRUs, and some of them are not, depending on the aircraft. Is that true or false? Okay, that's true. Okay, it just depends. 88. The 2 check valves on the PTU manifolds are different from the check valves that are on the high pressure manifolds. Okay, on your HP manifolds. Is that true or false? That's actually false. They're exactly the same. Okay, at 89, beware too, by the way, if you know, an instruction, specifically if I say, you know, something is not interchangeable, then it is not. Okay, and you want to be careful with, you know, paying attention to when you get a part handed you, or you pick a part to replace something, and making sure that it's, you know, that it's the right part number. They may look physically the same, but, you know, it may not be the right one. Okay, 89, regarding PTU operation, with inch master 1 and 2 in the on position, the ECAM will show a PTU fault indication under what conditions? When will that PTU fault indication show up? Okay, you have 2 choices. When a more than 650 psi difference between the green and yellow systems, you know, when there's a more than 50 psi difference for more than 4 seconds, or a more than 750 psi difference for more than 6 seconds. Okay, the answer is the first one. It's number 650. Okay, number 90. The PTU gets activated when there's an estimated 500 psi pressure more in one system than the other. Is that true or false? Okay, that's true. Okay, 91. The blue auxiliary system supplies power from what component to the blue main system? Is it PTU or the rat? And yes, it's the rat. Okay, 92. In addition to supplying hydraulic power, what other power can the blue auxiliary system supply? Okay, I mentioned it earlier, but okay, your two choices, electrical or pneumatic. Okay, the answer is electrical. Okay, so 93. What two components are installed at the hub of the rat? Is it the oil valve and pitch change or pitch change mechanism, or is it the mechanical governor and pitch change mechanism? Okay, it's the latter. Okay, the last one. Okay, 94. What is the rotation speed of the turbine? What's the range? Is it 4,800 and 6540 RPM or 5020 and 7040 RPM? Okay, that's the first answer. All right, so regarding the blade pitch angle, what does the governor do? Okay, option 1, mixes the spring and governor, or option 2, it mixes the blade counterweight, spring, and governor. Okay, it's the latter. Remember I said remember the blade counterweight. That's going to be your sign there. Okay, 96. The turbine is attached to the upper end of the leg assembly. Is that true or false? All right, that would be false. It's at the lower end of it. 97. What is the purpose of the index mechanism on the front of the leg assembly? Okay, is it to lock the turbine hub assembly in the correct position or to unlock the turbine hub assembly? Okay, I talked about that. It's the first answer, right? Okay, 98. The leg assembly is a mechanical and hydraulic connection between the pump assembly and the aircraft. Is that true or false? That's true. Okay, 99. The hydraulic pump has which system installed? The de-icing system or the anti-stall system? Okay, remember I just talked about that. Okay, the answer is the anti-stall, right? Okay, 100. Ratman on the 40 VU, when operated, connects the 28 volt power, okay, from the hot bus 1 to solenoid 1. Is that true or false? Okay, that's true. Okay, 101. Rat and emergen, when operated, is going to connect number 2 battery to solenoid 2. Is that true or false? Okay, that's true. I mentioned that. Okay, 102. What other component gets the 28 volt power when the rat and emergen is operated? Is it the control unit of the CSMG or is it the hydraulic pump? Okay, it's the control unit of the CSMG. Okay, 103. The rat control panel has an interlock warning light. Is that true or false? Okay, that's true. Okay, 104. The index lock mechanism automatically disengages when the rat is at how many degrees away from full extension? Okay, it's 5 or 15 degrees. Those are your choices. Okay, it's when it's 5 degrees away. 105, the rat can be retracted both when the plane is in flight as well as when on the ground. Is that true or false? Okay, that is false. Remember I kept mentioning that it has to be done from the ground. Okay, 106, before you start the process of rat retraction, what 3 conditions must be in place? All right, so your 2 choices are, okay, the first choice, the turbine is in its index position, 28 volt DC supply is there for the rat control panel, and you have a pressurized blue main system. Okay, or is it option B? The turbine is in its index position, 28 volt DC supply for the rat control panel is there, and an unpressurized blue main system. Okay, the answer is, okay, it's the first one, first choice. Has to be pressurized. Okay, 107, what triggers the warning light on the rat control panel to go off? Okay, your 2 choices. High pressure supply to the solenoid in the rat ground retraction module, or option 2, rat ground retraction module's flight position stopping the high pressure supply to the jack. Okay, that would be B. That would be the second choice. Okay, one more question. Okay, what triggers the warning light on the rat control panel to stay illuminated? Okay, your choice 1 is a pressure switch from continued high pressure supply or an actuator. Okay, I think you got this one. Okay, the answer is the first one. First choice, right? Okay, so that's a lot of questions, but I want you to get it more in your head, that's all. And not all of them necessarily will be test questions, but you're going to be walking away with more knowledge than you expected, I think. Okay, so this concludes definitely the the hydraulics, and if you have any questions at all, please reach out to us through email, and we'll be more than happy to to help you out. Also look out for our commentaries, because we're going to have commentaries from our airline pilot and also from our aircraft maintenance technician here at Operation Aviation.